Hi guys, Mr. Rocco. This is the week of October 26th. This week we're going to be focusing on topographic maps. This is a computer program that I've used in past years. It's called Introduction to Topographic Maps. I'm going to be making a few short videos with some of the contents in this computer program. Not all of them. I'm going to go through the introduction here, general topographic map information, a little bit on latitude, longitude, which is a review, but it's good. Principles of contour lines, how to use contour lines, and drawing a contour map. Topographic profiles I'm going to save for next week. So I'm going to do intro, general topographic map, lat longe, principles of contour lines, using contour lines, and drawing contour map. This might be over a couple of videos, but I'm going to start with introduction. So here we go.
Introduction. Maps are important research tools that provide a method for reducing large amounts of information to a manageable size. There are many types of maps that simplify and present the variety of different features and patterns found on Earth as they would appear from an overhead view. Maps can be as simple as showing the way from your home to your post office. And everyone has seen a road map that illustrates the highways and roads that connect cities. Some maps show patterns like soil types, landforms, or precipitation, and are very useful. One special kind of map, called a topographic map, illustrates with great accuracy the vast amount of physical and cultural features that occur on Earth's surface. As detailed, scale model, overhead representations of Earth's surface, topographic maps are indispensable tools for geologic and land use studies, planning, and construction. Earth scientists use topographic maps to determine locations, elevations, landform types, and other physical data. Topographic maps have been produced by the United States Geological Survey since the late 1800s. General topographic map information. Topographic maps that are produced by the United States Geological Survey follow a similar format. In addition to using standard colors, each map contains information on map location, date of mapping, scale, etc. Each topographic map is given a name for reference. The name of a topographic map is given in the northeast corner of the map. What is the name of this topographic map? Type your answer in the space above. Click the map icon below to refer to the electronic map. Zoom in to the portion of the map which answers this question and return.
So what you would do is up here in the top right corner, that's the northeast corner, you would zoom in. Let's see if that works. So you would zoom into this corner. This is an interactive computer program, so I'm just gonna go through bits and pieces, not everything in here. So you can see up here, these topographic maps are called quadrangles, and they cover 7.5 minutes. So you remember latitude, longitude, which we covered, a degree of latitude and longitude is equal to 60 minutes. So these maps cover 7.5 minutes by 7.5 minutes. Anyway, so this one's called the Southwest Pueblo Quadrangle, which is in the state of Colorado. So you would go in here and just type in Southwest Pueblo. And then over here you'd say, is this right? And it'll tell you if it's correct or not. So it's interactive. Like I said, we're going to skip through certain parts.
Notice the small reference map in the bottom margin of your map. In what general area of the state is the area represented by this map located? Click on the correct answer.
So again, you would zoom in. Down at the bottom of the map, they give you the state of Colorado. If I zoom in there, and you can see that little dot right there. So that would be considered what? East Central. So I would click on that. And you see we're right. If you were wrong, like let's say I pretend, oh, let's pick Northwest. And then say, is this right? And we're wrong. But that's okay. We got it right the first time.
Direction on a topographic map is indicated by a diagram located within the lower margin of the map. Several norths are indicated. True north, indicated with a star on most USGS topographic maps, shows the direction to Earth's geographic North Pole. Magnetic north, indicated with a MN, is the direction a compass needle points. The magnetic North Pole is located northwest of Hudson Bay, approximately 500 miles from the geographic North Pole. Earth's magnetic pole moves slowly but constantly over a small area, which causes slight variations in the direction a compass needle points from year to year.
So magnetic north changes from time to time, and that's because the magnetic field that surrounds the Earth is affected by the sun, and that is going to fluctuate from year to year.
Since Earth's geographic North Pole is different than its magnetic North Pole, and only in a few areas do the two align, magnetic north is also indicated on the diagram. The MN arrow shows both the direction that magnetic north is from true north and the number of degrees that magnetic north varies from true north. In the example shown, magnetic north is 12 degrees or 213 mils to the east of true north.
Yeah, don't worry about the mils, but they're just showing you the difference in degrees between true north, which is the North Pole, 90 north latitude, and magnetic north. And in this case, it's 12 degrees. They call that the magnetic declination. Wouldn't worry too much about that. That's not going to come up on our regions. But just FYI.
The difference between true north and magnetic north is called the magnetic declination. Note, the size of the degrees on the diagram are exaggerated to allow for easy reading and, since the magnetic declination of a place can vary from year to year, the year of the declination is also often given. On newer topographic maps, a third north, called a grid north, is also indicated. Grid north shows the relation between true. To visualize the effect of magnetic declination at various locations in the U.S., drag the compass across the map. Observe the different colors used for the various symbols on a USGS topographic map. The principal colors are red for major roads and highways and some boundaries, black for buildings, secondary roads, some boundaries, and other artificial features, salmon for urban areas, green for vegetation, blue for rivers, streams, or other water features, brown, primarily for lines called contour lines that show elevation, and purple, for revised map features added after the map was originally produced. U.S. Geological Survey topographic maps also use a variety of symbols to illustrate features. Click on the Map Symbols button below to view the symbols used by the USGS. Use these symbols to help you complete the following activities.
So we're not going to do any activities. I'm just going to click on the map symbols just to show you all the different symbols. There's a ton of symbols out there. You don't have to memorize them. There's some basic ones you should know, like what's the symbol they use for a school, a church, cemetery, things like that. So I'll show you some of these here. Let me click on map symbols. Takes a minute to boot up. This is a CD program. So if I open this up, you click on roads, and then it's going to show you primary highways in red, secondary are red and white, like dashed, light duty roads, light duty if it's paved, light duty road if it's gravel, light duty road if it's dirt. I mean, there's symbols. Four-wheel drive roads. You can scroll down here. If it's got an overpass, if it's got a drawbridge, it's got a tunnel, there's a gate. Let's see, keep going down. Here's some railroad features. So standard single track railroad, multiple tracks, a railroad on a highway, a railroad with an underpass or overpass, a railroad with a drawbridge. I mean, like I said, this goes on and on and on. Let's go to buildings. Buildings can be different size boxes depending on obviously the size of the building. Schools will have, I don't know if you can see that, it's a little box with a flag on top. If it's a church, it's a little box with a cross on top. Athletic fields, racetracks, let's see, airports. If you got underground tanks that hold different things like gasoline and stuff. Roadside areas, picnic areas, campgrounds. Cemetery could be a dotted box with a a cross, and or the word CEM or the letter CEM. Mines and caves, that one comes up often. So it's a quarry. They use a little rock, a little hammer, and a pickaxe. What else? I'm trying to think of ones that you might see. I wouldn't worry about pipelines and telephone lines. Surface features, okay, so levees, sand, gravel. Oh, here we go, rivers. So if it's a perennial stream, perennial river, intermittent streams will sort of flow, then they kind of slow down, then they speed up again. Falls, large falls, small falls, rapids. If you have a dam, what else? Canal, aqueduct, a spring, a water well. Then you have, let's see, coastal features, coral reef. If you have a shipwreck that's exposed, a seawall, a jetty or a pier. Like I said, this just goes on and on and on. So I went through a bunch of them, but there's lots and lots of symbols that, again, you're not expected to memorize them. So the school I would know, maybe the church, maybe a rock quarry, a few simple ones.
Drag the answers to their appropriate boxes.
Now we're going to skip some of this stuff.
Drag the In addition to using various symbols, USGS topographic maps also include the names of places and features. What is the name of the river illustrated in the southeast corner of this topographic map? Type your answer in the space above.
Again, we're going to skip past that. Let me go back to the home page. Let's look at latitude and longitude.
Location, latitude, and longitude. Because topographic maps are drawn with great accuracy, one of their most useful functions is determining the precise location of features on Earth's surface. Two methods that are frequently used are latitude and longitude, and the Public Land Survey System.
We're not going to worry about the public land survey. We're just going to focus on latitude and longitude.
Latitude is distance north or south of the equator. Latitude is measured as an angle from the center of Earth, north or south of the equator. The lines of latitude are called parallels. Places north of the equator are designated north latitude, while those south are south latitude. Longitude is distance east or west of the prime meridian. Longitude is measured as an angle from the center of Earth, west or east of the prime meridian. The lines of longitude are called meridians. Places east of the prime meridian are designated east longitude, while those to the west are west longitude. Since parallels and meridians mark distances on a sphere, their designation is in degrees. For more precise location, a degree can be subdivided into 60 equal parts, called minutes, and a minute of angle can be divided into 60 parts, called seconds. Move the mouse around the map to see the latitude and longitude displayed below.
So you can see when I move this cursor around, and down at the bottom of the screen they give me the latitude in degrees, minutes, and seconds, and the longitude degrees, minutes, seconds. Right, so if you notice, this is 40 north, this appears 50 north, so this would be 41 north, right, 42 north, 43, 44, 45, etc. And then this is 10 east, this is 0, so here's the prime meridian, and you're going east of the prime meridian, so this would be 1 degree, all right, 2 degrees east, 3 degrees, 4 degrees, etc. But you can see it goes down to real specifics depending on where I put the mouse.
On a topographic map, latitudes and longitudes are shown at the four corners. Latitudes and longitudes are also shown at intervals along each margin. What surface feature is located at 38 degrees, 10 minutes north latitude, 104 degrees, 39 minutes, 30 seconds west longitude? Click on the correct answer.
We'll skip this.
What surface feature? In addition to latitude and longitude, another method used for designating location on Earth is the Public Land Survey. It is the system used throughout much of the central and western United States to identify land, such as might be described on a property deed.
Again, we're going to skip through this. I'm just going to see if there's anything else important in this section. I don't think there is.
The public land in in what direction for more precise descriptions, quarters, or while drag the Public Land Survey.
Okay, sorry if that's a little annoying. We're going to skip past that, and we're going to go right to principles of contour lines. Actually, what I'll do is I'm going to stop here, and that'll be the first video. And then I'm going to pick up with video 2 with, I'm going to do principles of contour lines, using contour lines, and drawing a contour map. So I got to cover those 3 sections in another video. Okay, but that'll be it for this video, and talk to you real soon. Bye.